All right. First things first, let's talk about the final exam. So, final exam is not optional. By the way, let's final exam is right here on the front page since the beginning of the quarter. Okay. So when you click on that, it's going to take you to this page. It's not optional. I mean, you can skip it if you want, but then I'll skip giving you the grades. So it's not optional, it's mandatory. But unlike other classes, mine is not very heavily loaded. It's about 20% of your overall grade. So it's just large enough to sting, but not bite. Our regular schedule exam is Monday from 1 to 4. Okay, 321, Monday 1 to 4. In addition, you have the option of taking it on a Saturday. The Saturday, that means this coming Saturday, before finals week begins. So some students like to take the non-E major classes done before the weekend so they can concentrate on their major classes, during the week. So, well, it's a major for me, yes. Yes, so I'll talk about it. So that's the first option, right? You either take it a week from today, it's easy to remember, in this classroom next Monday at 1 o'clock, class time, right? Easy to remember. So for that, you don't need to submit a form. You don't need to let me know. You just have to show up next week. If you do want to take it on a Saturday or any other option other than the scheduled regular time by the university, the other three options, you have to submit this form. If you want to take it on the Saturday before finals week, meaning this coming Saturday, all you need to do is fill in your name and let me know that you're going to show up. Otherwise, I may not have an exam for you. Okay, so I will only print out enough exams to accommodate the number of students. Yes. So the location, right now I'm trying to, I think I'm almost set on room number 126 in building 20. So I'll note it in there. But room number 126 is the room opposite my office. It's the classroom opposite my office. And the reason I'm putting it over there is because all of these classrooms are university controlled. And so on a Saturday, I might not have access to these rooms without making some sort of special arrangements prior to it. So rather than deal with all of that, I'll hold it in, in the building, in the EE building. Yes. I haven't designed it yet, but no. It's up to the students. So typically my finals, students, I would say the earliest students start leaving an hour and a half into the exam, around 50%. On average, some students might sit there for 2 hours, and then some students like to sit there the entire 3 hours. Yep. So you did. So, but I would say 2 hours or less. 2 hours or less. If you don't want to take it on a Saturday and you don't want to take it on the Monday, the other two options are Monday, 10 o'clock, which is before your scheduled time, which I'm assuming no one's going to do. And then the other option is Wednesday at 7 o'clock in the morning. If you do want to take it at any of those times, either Monday 10 or Wednesday at 7, then you do need to submit that form as soon as possible, because that exam will be in this classroom and the seating is limited. Okay. And again, that will be the day when I have my 201 exams. So you need to let me know that you're going to show up. Otherwise, I may not have a 321 exam for you. Okay. No matter which day you decide to take the exam, it'll be, well, they're all going to be different, but of similar complexity, similar level. It's not going to be too far, a lot of difference. The questions and the problems will be different, but very, very similar. Okay, the level of complexity is going to be the same. So if you take it on a Saturday or you take it later, you're not going to gain an advantage or be at a disadvantage. Okay, it'll be very, very similar for all students. So decide and then, well, submit in the form. If you don't submit the form, then I will assume that you're going to show up on Monday, next Monday at 1 o'clock. Yes. There's no deadline as such. I plan to print the exams on Thursday or at least the Friday, before Saturday. So even if a student sends me something like maybe Friday afternoon, Friday evening, I would still be able to accommodate for the Saturday. So, but again, as early as possible, that would give me enough time to plan. And I will also post here what you need to actually, the topics that I'm going to be covering. Well, eventually, I mean, we have 4 chapters and 4 topics. We have 4 course outcomes. If you think back to the first day of class when I went over the course outcomes, one is diodes, Zener diodes, one is transistors, op amps, logic circuits. The 5th one is kind of like an introduction to computer architecture, which we'll do on like Wednesday. Yes. Very similar. Yeah, very similar. So homework, quizzes, similar to that stuff. Yes. Yes, what you would see in the exam. So now, in college, and I've mentioned this before, many times students would say, I took this class and the exam was nothing like what we did in the entire quarter. There is a reason for that, because as engineers, you're expected to take your learning from here and go out in the industry. When you're working as an engineer, you will always be working on a problem that you have never seen before, right? As a working engineer in your own fields, you're going to work on problems that you've never seen before, meaning you are required to form higher order connections based on the learning that you've achieved. And that's why some of the professors like to do that. I typically don't tend to do that. I might require students to do some thinking, but not a very high level of higher order thinking. Okay, does that make sense to all of you? But if some professors do it, then that's the reason why they do it, is because students are expected to form higher order thinking or higher order connections. Yes.
How is the course evaluation participation rate going?
I haven't calculated it yet, but it's decent enough. I mean, there's enough extra credit in there for everyone. Yeah. Yeah, I'll send an email about that. But yeah, but he's talking about the weekly one. He's talking about the weekly one. All of them together. Well, all of them put together is about 3%. I don't know if several students might have already forgotten about it. So let's see, equation sheet, class prep. So it will be about 4 to 6 questions. Each targeting like one topic. That's what I'm envisioning right now. Let's see, some informative quizzes. Yeah, that about covers it for the final exam. All right, any other questions? Yes. Yeah, one per topic. Yeah, 1.5. So like, if you're addressing diodes will have the general diodes, and then we also have the Zener diodes. So I might have like 1.5 questions there, BJTs, some fundamentals, and maybe a circuit analysis, load line, and then op amp amplifier circuits, and then logic circuits. So I might have like 2 questions perhaps. No, I don't know. Well, the reason is, so that's another part I was going to address. So quiz 7 at the beginning, this is the last quiz. You don't have any more quizzes unless you want to take some. I can have one on Wednesday, have one on Friday, then you can decide if you want to drop any. Now, the goal at the beginning of the quarter, if you remember, I always like to say that I like to do 7 to 9 quizzes. And 7 quizzes, about 15-20 minutes in length. If you work it out, is actually more, if not more, at least equal to 2 midterms. Okay, so rather than do like 2 midterms, like 50, 100 minutes, devoted in 2 classes, I like to spread them out. Slightly less pressure on the students. And, you know, it's just, I think it's just better that way. That's just my personal opinion. Anyway, so target is always like 7 to 9. In the fall quarter, usually we have slightly, you know, 1 or 2 extra days. So fall, I'm able to like squeeze in about 8 or 9 quizzes, including like the Thanksgiving break. So yeah, you remember, right? Yeah, it showed up in my evaluations. One of the comments was, is it even legal to give a homework on? Anyway, coming back on track, it's the way I see it is 7 quizzes is equal to at least 2 midterms, at least, if not more. Okay, so 7 quizzes is a good, decent amount. And we pretty much covered like every topic starting from before. Now, obviously, it's a non-E major class, so we are like just skimming the surface. There's so many things that we can go, you know, in depth into. But again, we just scan the surface, not go too deep in there. All right. Let's see. Time has gone by. Any other questions about the exam? Yes. I do need to work on them. There's a student who did it. Eric reminded me, and I need to do it, and then I still need to do it. I'll go ahead and post it. This one I just designed this morning, so I have no idea what the answer is. I have to sit down and do it myself. Let's see. Oh, yeah. Let's.
Sir?
Yeah, was there a question?
Yeah, that the equation sheet, do you need the 1-inch margins on that?
1-inch margin? No, not for the equation sheet.
Okay, so front and
Not
back.
for the equation sheet. You can
front,
fill it
back,
up as
paper.
tiny or handwriting as you can possibly manage for the equation sheet. Yeah. Yeah, both sides. Both sides. Resonant circuits. So let's go shift registers. I realized there were some questions and yeah. There are some questions about how it works, right? So shift registers are made from D flip-flops. Okay, the output of each D flip-flop is connected as input to the next one. Okay, D flip-flop is basically a delay flip-flop. Okay, there's a delay in when the input reaches the output, and that delay is measured in terms of the clock speed. Okay, so we are thinking about the delay flip-flop. Oh, that was J and K. D flip-flop. D flip-flop simply takes whatever input comes at the D terminal and connects it to the Q output terminal. That's it. That's all it does. Okay. So when the flip-flop is activated,
we
E
can't see the
gets connected
slides.
to Q. Sorry, was there a question?
We can't see the slides. We're all
Oh,
on
you can't see the
Canvas still.
slides. It's not being shared.
Yeah.
Oh. How about now?
Yeah, we can see it
Okay.
now.
All right. Thanks. So all it does is the flip-flop is either activated or not activated. Okay. If it's not activated, the output Q is basically the previous state, meaning it's holding the output. It's storing it as a memory. So it's also used as memory. Okay. It's 1-bit memory. If Q is 0, it stays at 0. If Q is 1, it stays at 1. When the flip-flop is activated, whatever is connected to D gets shifted to the output. If D is 0, Q is 0. If D is 1, Q becomes 1. So that delay is basically the clock input. So when you're analyzing a D flip-flop, you only have to look at whether it's activated or not. If it's not activated, it's previous state, meaning it's Qn minus 1, Qn minus 1. If it's activated, then you see what value D has. Whatever value D has is going to be shifted to the output. Does that make sense to everyone? Yes.
That entire QN column, that's the output of Q. So Q not between the input.
Yes, always. Yeah, always. So in this case, the activation depends on the clock input. And here we have the knife's edge. So it's a edge triggered, and there is no bubble, meaning it's a positive edge triggered flip-flop. Every time the clock transitions from 0 to 1, meaning it's going high, a positive transition, then the flip-flop is activated. For all other inputs, clock inputs, the flip-flop is deactivated. Okay, the flip-flop is only activated for a positive edge trigger. For all other values, doesn't matter what it is, it remains in the previous state. So there are only two cases. When it's activated, D can take 0 or 1. So Q can be 0 or 1. That's the D flip-flop. So remember I said, if there is no clock, it stores the data. It stores the previous state. It holds the previous state. So we can say it works like memory. It's a 1-bit memory. And so that's the building block for a shift register. A register, as the name suggests, registers the input and sends it to the output depending on the clock. Okay, so shift registers are so called because they shift the data bit by bit, either in or out. Okay, and depending on the mode of shifting, you can shift it either serially, meaning 1 bit at a time going in one line, or you can shift it all in parallel. So you can have serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. If you've seen old computers, they used to have 2 ports on the back, serial port and parallel port. The parallel ports were the ones where you used to connect the printers. All the data would go all at once out. Since it's going in parallel, you need more lines, right? So if you're a 16-bit bus, then you need 16-bit parallel lines. That's why parallel ports were much bigger than serial ports. So in this shift register right here, we have D flip-flops. The D flip-flops output of each flip-flop is connected as input to the next one. And we're also taking the output Q0 to Q3 as parallel outputs. Data enters from the far left. Clock is positive edge triggered, meaning every time the clock transitions from low to high, meaning from 0 to 1, each of the D flip-flops gets activated. So whenever it gets activated, what happens? Whatever is present here at D0 shifts to Q0. Then upon the next clock cycle, this shifts to Q1. And then so on and so forth. So every clock cycle, the D is connected to Q. So if you start off at the first clock cycle with 0 over here, first clock cycle, Q0 is 0. Next clock cycle, Q1 becomes 0, Q2 becomes 0, and Q3 becomes 0. And so it keeps shifting forward. And hence the name shift register. Yes. No, because for one clock cycle, if this is 0, now the next one, if this becomes 1, then all the rest are zeros, but my data input is 1. The next clock cycle, Q0 becomes 1, but the rest are zeros. So it would go like this: 0, 0, 0, 0, 0, 0, 0, 1. And then if there's another 1 coming after it, this becomes 0, 0. This one shifts out. This becomes 1, 1. Another 1 comes in. This 0 shifts out. This becomes 0, 1, 1. Now, if a 0 is coming in, this 0 goes out. This becomes 1, 1, 1, 0. So depending on what is coming in as the input, this is the left side of the circuit. Depending on what is coming in as the input, the other part is shifted out. So this would be Q0, Q3. And hence, this is the timing diagram that we come up with for a serial in, parallel out shift register. It's a 4-bit shift register, right? 4-bit Q0 to Q3. Clock standard clock, rising edge. There are 4 instances of the rising edge, right? 1, 2, 3, 4. Data was already 1 before the clock came in, but because the rising edge is not until this time period, Q0 does not change. So initially, all 4 are zeros. Q0 to Q3, all are zeros. Nothing moves, nothing is shifted. But as soon as the clock arrives, this one shifts to Q0. Right? And then this Q0 is the input to Q1 or D1, if you will. But that doesn't change until the second clock pulse arrives. When the second clock pulse arrives, the data in at the far left of the circuit goes to 0. So now Q0 goes to 0 after here, right? Second rising edge. Second rising edge. Data goes to 0 before the clock rising edge arrives, but flip-flop is going to remain deactivated because second rising edge has not arrived. Once the second rising edge arrives, whatever the data is here gets shifted to Q0, so it becomes 0. And then this is given as input to the next one. So when the second rising edge arrives, Q1 takes on the value of Q0, and hence Q1 becomes 1. So it's shifting all its way towards the right. Cascading connection, going all the way from Q0 to D1, Q1 to D2, and Q2 to D3, and so on and so forth. And so it keeps shifting the memory right there. Depending on the configuration and depending on the data that is being sent, well, the timing diagram would be completely different. But again, you have to keep in mind, the flip-flops do not get activated until and unless a rising or a falling edge arrives. So you identify, first thing you do is identify whether the flip-flops are positive edge triggered or negative edge triggered. Then you mark out the edges. If it's a positive going edge, mark out the positive going edges. If it's a negative edge triggered, you mark out all the negative going edges. Those are the only times when the flip-flops will be activated. That's the only time a transition would take place. Then you take a look at the input. For Q0, the input is data. For Q1, the input is Q0. For Q2, the input is Q1. For Q3, the input is Q2. And so from that point on, it simply becomes a case of taking a look at the data and then shifting it to the output. Does that make sense? It might take a while to actually grasp it, but that's what the shift register is. And so it shifts all the data into the memory. And at that point, if you can take it out serially also, meaning if you take the output at Q3, you can have serial in, serial out, or you can take all of them out in parallel. So it becomes serial in, parallel out shift register. So this is a 4-bit parallel register. Yes.
So for that case in Q1, then we need to go see the rising edge is in Q of the we do the Q0 as the label is 1.
Yeah, but here it's 0, so input for Q2 is 0. So it doesn't activate at rising edge of 2. I mean, it's just getting 0. It gets activated. All flip-flops get activated at 1, at 2, at 3, at 4. But the input for Q3 is Q2. Q2 is 0. So Q3 is 0. For Q2, until here, Q1 is 0. And so Q2 also remains 0. Yes. No, we are not talking about Q naught at all. Yeah, but essentially, yes, Q naught will be 1. If we were to plot Q0, are you talking about Q0? Okay. Q1 is dependent on Q0, yes. But again, it won't get activated until the rising edge arrives. So think of it this way. All the flip-flops are going to activate at this clock, at this edge, right? What is the value of Q, what is the value of data at this pulse edge? It's 1. And so this becomes 1. But when the first edge arrives, what happens to Q1? Q1 input is Q0. The Q0 is 0. That's why it stays at 0. Not here. It stays at 0 right here. Now, even though Q0 has changed to 1, the clock pulse hasn't arrived. So the flip-flop is still deactivated. It will only activate when the next positive pulse arrives, visit basically at 2 right here. Yes.
So just to clarify, the input to like into the is gonna be what's before the clock.
Yes. Yep. Condition would be the other, yeah, the other side. Yes. So we would just negative edge trigger would be here negative going values, going from 1 to 0, going in the negative direction here. All right. So let's stop here today.